So some questions we will see. What determines the rate at which the energy is delivered by a current? So electric power P determines the rate at which the energy is delivered by a current. Okay, this is the answer. Now one problem is asking an electric motor takes 5 amps from a 220 volt line. Determine the power of the motor and energy consumed in 2 hours. So we will see what he has given. Given is equal to takes 5 amps, that means I is given. I is equal to 5 amps and V is given. V is equal to 220 volt and determines the and time is given 2 hour. So T is equal to 2 hour and what we have to calculate? Power. P is question mark and energy is question mark. E is equal to question mark. Just you see here, T is given in hours, so that we have to change it to seconds. So I will show 2 hour. So hour we want to cancel. I have written denominator. So 1 hour is equal to 60 minutes. Again minutes I want to cancel. So 1 minute is equal to 60 seconds. So minute cancel, hour cancel. Now what is left? 2 into 60 into 60 seconds. Okay. So if we simplify this, 6 6 the 36 into 2. It is 72.00 seconds. So small t is equal to 72.00 seconds. So what we have to calculate now? Now P we have to calculate. P is equal to Vi. So V is given 220 volt into I is given 5 amps. So if you simplify this, you will get 1100 watt. So P is equal to 1100 watt. Now energy we have to calculate. So energy is equal to P into T. So P we have calculated, that is 1100 watt into 7200 second. If you simplify this, you will get 7.92 into 10 to the power of 6 joule. So E also we got. So after completing all this, you have to tell the power of the motor is 1100 watt and the energy of the motor, the energy consumed in 2 hours is 7.92 into 10 to the power of 6 joule. That you have to mention. See next question. A piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then the ratio of R by R dash is how much? He is asking. See, just here you see this sentence, you see a piece of wire of resistance R is having one resistance R. So this is cut into 5 equal parts. 5 equal parts. That means R by 5 ohm each. Correct? Na? Each. Then it is connected in parallel. These 5 resistances connected in parallel. So equivalent resistance of this is 1 by 4. Whatever you are getting answer, na, that is 1 by R dash. 1 by R dash is equal to, that is 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3 plus 1 divided by R4 plus 1 divided by R5. So which is equal to 1 divided by R1 means 1 divided by R by 5 plus 1 divided by R by 5, because it is cut into 5 equal parts, plus 1 divided by R divided by 5 plus 1 divided by R divided by 5 plus 1 divided by R divided by 5. 1, 2, 3, 4, 5. If you simplify this, you will get 5 by R plus pi by R plus pi by R plus pi by R plus pi by R. You take pi by R common factor, pi by R. So what is left? 1 plus 1 plus 1 plus 1 plus 1. So if you simplify, 5 divided by R, 1, 2, 3, 4, 5 into 5. So which is equal to 5 5 is 25 R. So 1 divided by R dash, how much we got? 25 by R. Now what you have to do? This you cross multiply it. That means R by R dash is equal to 25. So you what is asking? R by R dash is asking. So R by R dash you got, it is 25. This is the answer. Okay. So next question is, which of the following terms does not represent electrical power in a circuit? So we know that electrical power formula P is equal to V square by R. R is equal to I square R. R is equal to VI. Just you see here, V square R is there. He is asking not represent the electrical power. Okay. And I square R. This is I square R. So I square also is there. VI is also there. So what is left? Only IR square. This is IR square. This is not in this formula. So this is the answer. So an electric bulb is rated 220 volt and 100 watt when it is operated in. So when it is operated in 120 volt, the power consumed will be. This is the second part. This is first part. So first part, what he has given? So V is equal to 220 volt and P is equal to 110 100 watt. Okay. So what we have to calculate? Power consumed at second part. Power consumed at 110 volt we have to calculate. So that is V is equal to V square by R. So this is power consumed at 110 degree. 110 volt. So we don't know the R. So we have to calculate R. Then R of bulb, resistance of bulb is equal to V square by R. Cross multiply this, you will get R is equal to V square by P. So that means you will get V square by P. So is equal to how much we got? V square is 220 volt whole square divided by power he has given 100 watt. So now we got R. You substitute R here. So here this is the second part. It is 110 volt. V is 110 volt whole square divided by R he has given. R we got 220 whole square divided by 100 watt. So if you simply simplify this, you will get 110 volt into 100 watt divided by 220 whole square. This is simplified, you will get 25 watt. That means power consumed at 110 volt is 25 watt. Here it is there. This is the answer. Two conducting wires of the same material, equal lengths, equal diameters are first connected in series. That means one series connection is there. Okay. And then parallel, and one more parallel connection is there. Across the same voltage also same. The ratio of heat produced in series, ratio is asking. That means PS divided by PP would be, he is asking. Now series we are having, first we will see series connection. That means R in series is equal to R plus R is equal to 2R. Okay. So what we have to calculate? Power in series. Power in series is equal to V square by R. R means we got 2R is equal to V square by 2R. So PS is equal to V square by 2R. Okay, this is clear. Now parallel. Same, 1 divided by RP is equal to 1 divided by R plus 1 divided by R. It is equal to 1 divided by, take common factor, 1 plus 1 is equal to 2 by R divided by 1 divided by RP. So if you cross multiply this, you will get RP is equal to R by 2. Okay, RP, resistance in parallel you got. Now you calculate P in parallel. So which is equal to V square by R. R we got R by 2. So that means V square divided by R by 2. If you simplify this, you will get 2V square divided by R. That means PP you got 2V square by R. Okay. What he is asking? Ratio of PS divided by PP. So PS we are having V square divided by 2R whole divided by. So equals has to come here. Whole divided by 2V square divided by R. If you simplify this, you will get V square divided by 2R into R divided by 2V square. V square cancel. R cancel. So now what is the left? What left there? So here 1 divided by 2 into 1 divided by 2. So that is equal to 1 by 4. So PS by PP is equal to 1 by 4. So that is equal to, that means ratio we have to tell PS is to PP is equal to 1 is to 4. So this is the answer. Now you see 1.1 is to 4, here it is. This is the answer. So here he is asking, a copper wire has diameter of 0.5 mm and resistivity 1.6 into 10 to the power of minus 8 ohm meter. What will be the length of this wire to make resistance R? So length is asking, how much does the resistance change if the diameter is doubled? So he has made the resistance double, he has made the diameter double, then what will be the resistance he is asking. So two parts he has given. One we will see one by one. Given what he has given, dia is given, D is equal to 0.5 mm and rho he has given, rho is equal to 1.6 into 10 to the power of minus 8 ohm meter and R he has given, R is equal to 10 ohm. And what will be the length of the wire? Okay, length he is asking. So we know that what? R is equal to rho into L by A. Now you see, rho he has given 1.6 into 10 to the power of minus 8 ohm meter into length he has given. No, length we have to calculate. No, this is wrong. Length you have to calculate. So L is equal to R into A divided by rho. So R he has given 10 ohm into A. A he has not given. But here just you see it is a wire. Wire means it is cylindrical or circular. So for that you will get an answer in mathematics. So that means A is equal to pi R square. So here you see what he has given, D he has given diameter, but here it is radius. Now just you see, once again I will explain. This is a circle, this is center point, this is one radius, this is one radius, R. So total is this dia. So that means D is equal to 2R. to R. That means R is equal to D by 2. Correct, na? So that means, so which is equal to 0.5 divided by 2 mm. And he has given mm. This also you have to change. That means by 1000 you have to make 0.5 divided by 2 into 1000 is equal to, you will get 0.5 by 2 into 10 to the power of minus 3 meter. This is the dia. So D is equal to 0.5 divided by 2 into 10 to the power of minus 3. Okay, now at least, now it is not a D, it is R. Okay. Now, area means pi r square. Pi r square, it is 0.5 divided by 2 into 10 to the power of minus 3 whole square divided by rho means 1.6 into 10 to the power of minus 8. So if you simplify this, you will get approximate 123 meter. So now the second part, what will be the resistance if the dia will become doubled? Okay, that means we are having two resistance. One dia is less, another one is dia is doubled. That means this is A1, this is A2. Okay, na? Now area 1, A1 by A2 is equal to, A1 means pi r square, A2 means pi, radius is doubled, that means 2 r whole square. So if you simplify this, you will get 1 by 4. That means A1 by A2 is equal to 1 by 4. Now A2 just cross multiply it. So A2 is equal to 4 cross multiply to left side, you will get 4 into A1. Okay. For the same length and the same material, what will be the formula? R is directly proportional to L by A. Okay. And R2 by R1 is equal to A1 by A2 is equal to A1 divided by 4A1. Correct, na? So which is equal to A1 cancel, is equal to 1 by 4. So that means R1, R2 by R1 is equal to 1 by 4, which implies just cross multiply this. So R1 is equal to 4 R2. You got the answer. Okay, hence the resistance becomes 1/4. No, this some mistake we have made. We want R2. That is R2 is equal to, because R1 is given, so R2 we have to calculate the resistance. So R2 is equal to R2 is equal to R1 by 4. So therefore, the resistance becomes 1/4 of the original one. Original, we are having 10 ohm. So if we increase the diameter, it will become 1/4 is equal to 1/4 of R1. So this is the answer. See here, the values of current I flowing in a given resistor for a corresponding values of potential difference V across the resistor are given below. Current and potential difference is given. Plot a graph between voltage and I and calculate the resistance of that resistor, he is asking. See here, ampere, you see this is the 4 highest and voltage is this is 13.2 highest. So usually y axis is marked for volt. So this is y axis and this is x axis. So this is volt and this is current. Okay. So here up to 13.2 you have to make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And here it is 1, 2, 3, 4. Okay. So he has given 0.5. This is 0.5. 0.5 and this is 1, this is 2, this is 3, this is 4. 0.5 to 1.6 approximate, here it will come. Okay. And next one is 1 and 3.4. 3.4 means approximate, here it will come. Next 2, 6.7 approximate, here it will come. And 3, 10.2 approximate, here. And 4, no, 3 means up to here, not this. 3, 10.2 and 4, 13.2 approximate, here it will come. So if you join this, you will get a straight line. You will get a straight line. Okay, this is A and this is B, and one triangle you make from here onwards, roughly. This is C. Now resistance is what? Resistance is equal to change in volt divided by change in I. So change in volt means what? 13.2 minus 1.6 divided by change in current, that is 4 minus 0.5. So if you simplify this, you will get 11.6 divided by 3.5. So again, if you simplify this, you will get R is equal to 3.314 ohm. This is the answer. So next question. When a 12 volt battery is connected across a unknown resistor, there is a current of 2.5 milliamp in the circuit. Find the value of resistance. Unknown resistor, that means R is asking. Okay. So given, we will see V is equal to 12 volt and I is equal to 2.5 milliamps he has given. This we have to convert it to amps. That means 2.5 into 10 to the power of minus 3 amp. Okay. So resistance is question mark. Correct, no? So according to Ohm's law, V is equal to IR. R we have to calculate, separate it out, V by I. So V 12 volt divided by I is 2.5 into 10 to the power of minus 3 amp. So if we simplify this, you will get 4800 ohm. This is a big number, so that's why you make it to kilo ohm. So for that you have to make 4.8 kilo ohm urine. That's all. So R is equal to 4.8 kilo ohm. So we got the answer. So next question. A battery of 9 volt is connected in series with resistors of 0.5, 0.2, 0.3, 0.4, 0.5 and 12 ohms respectively. How much current would be flow through the 12 ohm resistor? He is asking. So he is having R1, R2, R3, R4, R5. So these are all connected in series. Okay. 1, 2, 3, 4, 5. So R1, R2, R3, R4, R5. He is asking how much current would flow through R12. This is 12 ohm. This is 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm. He is asking how much is current flowing through 12 ohm resistor. Okay. Now we will see all are connected in series. Okay. So what he has given? Given voltage he has given 9 volt and R1 0.2 ohm, R2 is equal to 0.3 ohm, R3 is equal to 0.4 ohm, R4 is equal to 0.5 ohm, R5 is equal to 12 ohm. So it is in series connection, that means RS is equal to 0.2 ohm plus 0.3 ohm plus 0.4 ohm plus 0.5 ohm plus 12 ohm. If you add this, you will get 13.4 ohm. So total resistance is 13 ohm. Now current we have to calculate. How much current is passing through it? So that means Ohm's law is equal to V is equal to IR. I we have to calculate. I is equal to V by R. So V he has given 9 volt divided by R we got 13.4 ohm. If we simplify this, we will get 0.67 amp. So I is equal to 0.67 amp. So now the question is, how much current would flow through 12 ohm resistor? So this is a series connection. Current is same. Series connection always throughout the circuit current is same. That's why the current crashing through 12 ohm resistor is 0.67 amp. So next question is asking, how many resistors of 176 ohm resistors in parallel are required to carry 5 amps and 22 volt or 220 volt line? Okay. He is asking how many resistors. This is parallel connection. That means RP. RP is equal to resistors divided by number of resistors we want. Correct, no? Okay. So current drawn is equal to V by RP. So that is equal to V by RP means R by N. If we simplify, we will get N into V divided by R. Okay. We want how many resistors? So that means N is equal to IR by V. So given what he has given, you see, given I he has given 5 amps, volt he has given 220 volt. Okay, is equal to I he has given 5 amps into R is equal to 176. So R also he has given 176 ohm. 176 ohm divided by volt is 220 volt. If you simplify this, N is equal to, you will get 4 number. So number of resistors are in 4, are connected in parallel. So this is the answer. So next question is, show how would you connect 3 resistors each of resistance 6 so that the combination has a resistance of 9 ohm and 4 ohm. Trial and error we have to do. They are having 6 resistance, 3 resistances. Three resistances, R1, R2, R3. Each resistance is same, 6 ohm, 6 ohm, 6 ohm. You want 9 ohm and 4 ohm. How will you will connect, whether it is parallel or series? So now I will try one series 6 ohm. Next to parallel I will try. This is also 6 ohm, this is also 6 ohm. So this is parallel connection, we have to sort it out. That means 1 divided by 6 ohm plus 1 divided by 6 ohm. To simplify this, 1 by 6 ohm is take outside, 1 plus 1 is equal to 2 by 6 ohm. 2 1 ja 2 3 ja, that means 1 by 3 ohm Okay, and this is 1 by rp na. So rp is equal to, you got 3 ohm. You add this. Now it has become series because we simplified this. You got 3 ohm. Add this. So 6 ohm plus 3 ohm is equal to 9 ohm. You got. So how you have to connect? For 9 ohm resistors, first one is series and next two is parallel. You will get a 9 ohm. This is one part. So second part, I will try like this. One and next one. Two in series. 6 ohm and 6 ohm. And one more, I will try parallel. This is also 6 ohm. Now what you have to do? This is series connection. Correct na? 12 ohm. And now 6 ohm, two are there. Now these two becomes parallel. So that's why 1 divided by 12 ohm plus 1 divided by 6 ohm. 1 by 6 ohm we take outside, 1 by 6 ohm take outside, you will get 1 divided by 2 plus 1. So this is equal to 1 by 6 ohm 3 by 2. Okay, I will write here 3 by 6 ohm into 2. 3 1 ja, 3 2 ja. So you will get 1 divided by 4 ohm. Okay, that is 1 by Rp. So if you want only Rp, you will get 4 ohm. See, you got answer. Okay. So here what? Just you have to make one line. Two resistors of 6 ohm are connected in series. So another 6 ohm is connected to parallel. So that sentence you have to make. So he is asking next question. Several electric bulbs designed to be used on a 220 volt electric supply line are rated 10 watt. How many lamps can be connected in parallel with each other across two wires of 220 volt line if the maximum allowable current is 5 amps? So what he has given? V he has given 220 volt. Okay. And I he has given I is equal to 5 amps. So that is maximum. So N is question mark. And P he has given. P is equal to 10 watt. Okay. Now N number of bulbs. N bulbs of power P. Each connected in parallel. Parallel will make the total power is equal to N into P. So we know that I is equal to P by V. P is what? Number of bulbs. So that is equal to N into P by V. We want to calculate N, separate it out. So N is equal to I into V divided by P. Okay. I he has given, it is 5 amps into V he has given 220 volt divided by P 10 watt. So if you simplify this, you will get 110 bulbs. So 110 bulbs can be connected to a given circuit, that is parallel connection with 220 volt line. Like that, one line you have to make. So here he is asking a hot plate of electric oven connected to a 220 volt line has two resistance of coils A and B. So each of 24 ohm resistance, which may be used separately, series and parallel. So what are the currents in the three cases? He is asking. He is having two resistances A and B, and he is telling each is having 24 ohm resistance. 24 ohm resistance. Individually you calculate the current. Series you connect and also calculate current. Parallel you connect and you calculate the current, like that he is asking. So okay, what he has given? V he has given 220 volt, and the resistance he has given 24 ohm. Now individual what you will get? So I is equal to V by R. So V is 220 volt divided by R is 24 ohm. You simplify, you will get 9.16 amps. In both of them, both if you take, same current will be flowing. This is individual. What about series? Series, that means resistance you will get 24 ohm plus 24 ohm, so which is equal to 48 ohm. Now I we have to calculate. I is equal to V by R. V is 220 volt and R is, we got 48 ohm. So if we simplify this, you will get 4.58 amp. This is series. Now parallel. Parallel means 1 divided by Rp is equal to 1 divided by A plus 1 divided by B is equal to 1 divided by 24 plus 1 divided by 24. 1 divided by 24 you take common factor, 1 plus 1 is equal to 2 by 24. 2 1 ja, 2 1 ja, 2 2 ja. So that means 1 divided by 12. That is 1 divided by Rp. So Rp is equal to, therefore Rp is equal to 12 ohm. Okay, now current we have to calculate for this. So this is parallel connection, this is series connection, this is individual connection is equal to V by R. So V means 220 volt divided by R 12. We got 12 ohm. So if we simplify this, you will get 18.3 amp. So IP you will get 18.3 amp, and IS you will get 4.58 amp, and individual you will get 9.16 16 amp. So this is the answer. So next question, compare the power used in 2 ohm resistor in each of the following circuits. 6 volt battery in series with 1 ohm and 2 ohm resistor. A 4 volt battery in parallel with 12 ohm and 2 ohm resistors. So here he is having two type connections. One is series and another one is parallel. And he is asking power used in 2 ohm resistor. So for series connection he has given us some data, that is V is equal to 6 volt, R is equal to R1 is equal to 1 ohm and R3 is equal to R2 is equal to 2 ohm. So now RS is equal to resistance in series is equal to 3 ohm. Correct, na? So he is having a two resistors in series. So this is 1, this is 2. So 1 ohm, 2 ohm, R1 and R2. So current flowing is same. Correct, na? Then I we have to calculate. I is equal to V by R. So V is given 6 volt divided by R we got 3 ohm is equal to 2 amp. So I is equal to 2 amp. Okay. Since current flowing is the same in both resistors, okay, power used in 2 ohm resistor is how much? So P1 is equal to I square into R. So we got I square, that means 2 square into resistance 2 is equal to 8 watt. So P1 is equal to 8 watt. Now we will go to parallel connection. Here what he has given, V is equal to 4V and the power used at 2 ohm resistor P2 is equal to V square by R. Okay. So V square he has given 4, that means 4 square. So this is parallel connection. He is asking at 2 ohm resistor. So that means this is 2 is equal to 16 by 2 is equal to 8 watt. So P2, how much we got? 8 watt. So compare between these resistors with power. That means P1 by P2 is equal to 8 watt by 8 watt is equal to 1. So ratio of P1 and P2 is 1. See here what he has asked. 2 lamps, one rated 100 watt at 220 volt and the other 60 watt at 220 volt are connected in parallel to electric main supply. What current is drawn from the line if the supply voltage is 220? So he is having two resistors, that means two bulbs. So this is R1 and this is R2. R1 and R2. This is 100 watt and this is 60 watt. So given what he has given for R1, V is equal to 220 volt. Okay, and P1 he has given. P1 is equal to 100 watt. So I1 we have to calculate. So second part also he has given V is equal to 220 volt and P2 is equal to 60 watt and I2 is question mark. That means here is connected one ammeter. You want to know the how much current it is consuming, and here also you connected one ammeter. You want to know how much current it is consuming. Okay. So now R1 is equal to V square by P is equal to V square. V square means 220 whole square. Okay. Divided by and also V square divided by P1 100 watt. So R1 is 220 whole square divided by 100 watt. So R2 you will see. R2 is equal to same 220 whole square divided by 60 and V square watt. Okay, now current consumed at R1, that is I1 is equal to V divided by R1 is equal to, so V 220 volt divided by R1, how much you got? This you can write it as 220 volt into 220 volt divided by 100 watt. So this still, if you simplify this, you will get I1 is equal to 220 volt divided by 220 volt into 220 volt. This will take it to top 100 watt. So 220 volt cancel. So we will get 100 watt divided by 220 volt. If you simplify this, you will get 0.45 amp. That means I1 is equal to 0.45 amps. So this much of current is flowing through R1. And second we will see, second. So R2, that means I2 is equal to V by R2. So V is equal to 220 volt divided by R2 means 220 volt into 220 volt divided by 60 watt. So if you simplify this, you will get 220 volt divided by 220 volt into 220 volt into 60 watt. So this one cancel. So you will get 60 watt divided by 220 volt. So if you simplify this, you will get 0.27 amp. Okay. So I2 is equal to 0.27 amp. Now current drawn from the line. So this fellow R1 is drawing 0.45 amps and R2 is drawing 0.27 amps. Then how much current they are drawing? So that is equal to I1 plus I2. I is equal to I1 plus I2 is equal to 0.45 amps plus 0.27 amps is equal to 0.72 amps. This is the answer. So here he is asking which uses more energy, 250 watt TV set in 1 hour and 1200 watt toaster in 10 minutes. See, he is having two instruments, that is resistors, one TV and one toaster. TV consumes 250 watt per hour. That means 250 watt hour. So TV is consuming 250 watt hour. Toaster we will see. Toaster 1200 watt per 10 minutes he is telling. Per 10 minutes. So this one we have to change it to hour. That means 10 minutes. So we want to cancel 10 minutes. We want hour. So 1 hour is equal to 60 minutes. So minutes cancel. 10 hour divided by 60. Now 1200 watt into 10 hour divided by 60. 0 cancel. 6 1 ja, 6 2 ja. So 200 watt hour. So much we got 200 watt hour. So now you compare this. This is also in watt hour and this is also now it is watt hour. Now you compare which one is consuming more energy. TV is consuming more energy. So here one sentence you have to make. Energy consumed by TV is more compared to the toaster timings. That you have to mention. Next question. An electric heater of resistance 8 ohms draws 15 amps from the service mains 2 hours. Calculate the rate at which the heat is developed in the heater. So what he has given? R he has given. R is equal to 8 ohm. I he has given 15 amps. And T he has given. T is equal to 2 hour. Calculate the rate at which the heat is developed in the heater for 2 hours. So that means you have to write rate of heat developed is equal to per 2 hours. So that means heat divided by time is equal to, so H is equal to, we know that H, I square R into T divided by T. So T cancel. What is left? I square and R. So I he has given 50 A whole square into R he has given 8 ohm. So if you simplify this, you will get 225. So 225 into 8. So which is equal to 1800 joules per second. So last question, explain the following. Why is the tungsten used most exclusively for filament of electric lamps? Tungsten is used almost exclusively for filament electric lamps because it is having high melting point and emits light at high temperature. Why are the conductors of electric heating devices such as bread toasters, electric irons made of an alloy rather than a pure metal? The conductors of electric heating devices such as bread toasters and electric irons made of alloys rather than pure metal because it has more resistivity and less temperature coefficient of resistance. Why is the series arrangements not used in domestic circuits? The series arrangements not used in domestic circuits because all appliances do not get same potential in series arrangements and all appliances cannot be individually operated. How does the resistance of the wire vary with its area of cross section? So resistance of the wire vary with its area of cross section because see formula you see R is directly proportional to L and inversely proportional to A. So A is area cross section. So area of cross section. So if area is increased, resistance will be reduced. So understood, I think you understood. So next question, last question, why are the copper and aluminum wires usually employed in electricity transmission? So wires we are using now, that question is asking. Why means copper and aluminum wires usually employed for electricity transmission because they are good conductors of electricity.